Hello and welcome to Talking Steam, a podcast series by Spirax Sarco. We are the world's leaders in steam technology, offering the industry's most extensive range of products and services across a variety of industries. We create solutions that set the benchmark for steam-using organisations worldwide, working with you to improve productivity, save energy, and reduce waste.
Hello and welcome to episode 3 of the Talking Steam podcast. In this episode, I'm joined by Katerina Rosa, a talented project development engineer from California, USA. We will be discussing the benefits that can be realised by recovering the energy and water from flash steam at a plant that is involved in the manufacturing or production of food and beverage products. We'll be explaining and giving examples of the fiscal and direct resource savings that can be realised, as well as revealing some of the less considered but equally significant benefits, which I'm sure you'll find valuable. In the last episode, we had a fascinating discussion with Ray McEwen, an energy engineer in the Europe, Middle East and Africa Spirax Sarco team, about recognising and investigating the plumes of steam that are often seen at food manufacturing plants. Today, we're going to be making reference to flash steam and other elements discussed in that episode, so I urge you to give it a listen. And so, on to today's guest. Katerina Rosa is a biochemical engineer. She joined the company in 2014 as an applications engineer for Spirax Sarco Chile, where her role was identifying and implementing improvement opportunities in the steam systems of manufacturing sites. Later, her specialism was working with manufacturers in the food and beverage industry and healthcare too. In 2017, she moved to the United States, where she joined the Spirax Sarco team, and she is currently based in Southern California. Katerina is also a certified energy manager with the Association of Energy Engineers, making her a terrific complement to this podcast and certainly a guest that I'm excited to have join me for this conversation. I'm Mike Skidmore, your host for the Talking Steam podcast, where in this series we are focusing on heat recovery opportunities at food and drink manufacturing sites. Just a very quick note to say that due to the 2020 COVID pandemic, this discussion was held virtually rather than face-to-face.
So Katerina, thank you for joining me today and a very warm welcome to the podcast.
Good morning, Michael. Thank you for inviting me.
Oh, it's my pleasure and our pleasure to have you on board. So we gave the listeners a very brief introduction to your background and in your experience, but can you please give us just a quick insight into how COVID has affected your work in the last year?
Well, here in the United States, as you all may know, has been very challenging. A lot of cases per day. Now we're in the second surge. And my work, I always work remotely, so that hasn't changed much. But definitely making visits to sites has been more challenging. We are holding all the meetings online, which is somehow a little bit better. Now my meetings are more focused maybe than before.
Safe to say as well that we're all very much looking forward to being able to have more of those human interactions. So Katerina, in the last episode of this podcast, we explored why plumes of steam can be seen as a plant and then the fundamental differences between them. And we identified one type of plume being from what we call controllable losses, which would be like a leaking safety valve or a passing steam trap. And then the other type of loss being what we called an unavoidable loss, which is coming from flash steam. And that flash steam coming from a process, which could be a process which is heating water or heating a product which is being manufactured, and inevitably is going to end up being lost through a plume if it's not captured or recycled. We understand that those unavoidable losses from flash steam present an opportunity there to recover energy and water. And that means our intention for this conversation definitely is something I'd love to explore a bit further with you. And when we go back to the previous episode with our colleague Ray, The analogy that we used there was of a hot water system, using a steam coil within the hot water or to heat the water. And as a result of that process, over 14% of the steam that was going into the process was then being lost to atmosphere as flash steam, which is a significant amount. So, Katerina, what are your experiences of plants losing flash steam? And again, from your experience, what has then been the cost to that manufacturer?
Usually, the how you call it, the unavoidable losses, most of them can be recovered. They are not controllable in the sense that it's not just repairing a valve or changing a steam trap, but as long as you have a heat sink, meaning a flow of water or that you're using for another process, you can always condense and utilize part of that. The manufacturer, for example, was using steam to heat some part of the liquor that they were generating before doing powder coffee or instant coffee. They were using water in another part of the same process, and basically both processes were located next to each other. So in my case, I went there to see the pump that was returning the condensate because that wasn't working. But we realized that there was in one side a plume of steam that was flash steam coming from this high pressure condensate. And right next to it, there was this other process that consumed hot water for the same process, but in a later stage. So the manufacturer was very frustrated with the plume of steam because their factory doesn't look sustainable. They are located in a very important sector of the city, and this brand is important. So, of course, they were worried about what the people think of their manufacturing site. So when we discussed about the possibility to even make a study about recovering that plume, they were very interested. And at the end, they ended up recovering $30,000 per year in energy. What began with the motivation of condensing the plume of the image of the factory ended up being a big source of energy savings for them. We use the plume of steam to preheat the water for the other process, and that in a great part condensed the plume.
What a great example. And there's a number of points there that I'd really like to draw out with you and explore a little further. So you said there that just by recovering the energy from that steam, that equated to a saving of $30,000 per year for that manufacturer or for that plant. So
yes.
That was replacing the energy that was previously being used to heat the water.
Yes, exactly. One part of the steam was being used to preheat that water for the process, and the other part of the steam was used for heating the liquor. So we took the condensate from liquor heating process and we sent it to a flash tank, and then from that flash tank we supply this steam that otherwise would be vented to atmosphere through a vent condenser. And in the vent condenser, we pass water that was from the other process. So in that way, we preheat the water, and then they had to use less live steam to reach their set point.
It sounds like a relatively simple execution as well.
No, it's very simple. When you use a vent condenser, most of the time you are just recovering whatever energy you can, and that will depend on how much water do you have, and that is not controllable because it depends on what process you're recovering the energy in. So we don't in general use any control valves or any controllers. It's just a simple bypass where you take the water that is going to your main process and do a bypass to pass it through this vent condenser. So it's relatively simple.
And where you're replacing steam which was previously heating the hot water or the hot liquor for the process, if that steam is being generated by burning a fossil fuel, what does that then mean for CO2 emissions?
Yes, of course. If you are reducing the amount of live steam that you're using in your process, I'm going to say live steam to make a difference from using flash steam, that is the plume that we are recovering. Live steam would mean the live steam that coming from your main steam generation process, your boilers. So, of course, if you reduce the amount of steam that you're using in your live steam that you're using in your production process, you are using less gas or whatever fuel you're using. And that can be translated into a reduction of CO2 targets.
That's something I've certainly come across working with certain manufacturers, where we are seeing targets which are becoming so much more public and thrust into the public sphere and advertised, where multinational corporations are aiming for like net zero carbon emissions by 2050. Some are aiming for net zero by 2040, and then others are maybe benchmarking, setting where their carbon emissions were in 2008 or 2010, and then saying that by 2030 they're going to be reducing those emissions by 80%, so hitting, by only then emitting 20% of what they were then producing in 2008. So we're looking at some really significant reductions, massive reductions across industry from the bigger players. And I think what you've explained there is a brilliant example of how energy savings within a steam system can really contribute achieving those targets.
Yes, for sure. It's something that the customers are always looking at, even if the policies in the meantime maybe do not support any bigger economical gains for them. It's something that also helps many products in their marketing, for example. Some manufacturers have the motivation of reducing the CO2 emissions because they want to have a better image. Their product has to look more sustainable. So the resources that they use to get to a finished product is relevant for the image of the product itself.
So, Katerina, in the example that you gave of your coffee manufacturer, you spoke about steam and reducing steam as the use of steam and how much steam was required in that process and the saving that came about from that. But also, where the flash steam was previously going to atmosphere, there would have also been a water loss there. Can you explain to us just a little bit more about what that means and what the consequences are of water loss from a system?
Yes, of course. When you use flash steam to preheat any other water flow or any other process, you are using your main process to condense that flash steam. So now, instead of having it being vented to atmosphere, now you are able to recover part of that energy, and that translate into this plume condensing back into water. You can reuse it for your process and condense it and return it back to the boiler. When you return more condensate back to your boiler, of course, you now have a better quality of feed water, because water that before was, city water or that needs to be treated to be put in the boiler. You need to do chemical treatment or use softeners or RO. Using water is always another expense, because you need to treat it before using it to generate steam. So if you increase your condensate return, then you're reducing the amount of water that requires treatment. So that's in the chemical side of the boilers.
I think that's something that could quite easily be taken for granted and almost overlooked when we think about the water. And you quite rightly touched on there that yes, if you lose 1 meter cubed of water to the atmosphere in the form of flash steam, what that actually means is not only have you got to introduce 1 meter cubed of water to replace it at the front end of the system back into the boiler, what you've also got to do to that 1 meter cubed of water is you've got to heat it up to be able to generate steam from it. But you've also got to then add chemicals to it as well to allow that steam to be generated correctly within the boiler and to maintain the longevity of the system. So it's not just a case of replacing water like for like. There is a number of other factors there that come into play. I think the other thing that, again, we're an awful lot more noise is being made about, and is certainly more prevalent in other areas of the world, is when we think about water scarcity too. And Katerina, have you ever worked with plants where the bigger driver is maybe not so much energy but water?
Oh yes, this is something very interesting because it changes in the same area from city to city, at least where I live here. And the motivations change quite a lot, and especially in the United States, which is a very huge country with different policies in different states, it's very different when you travel from one side to another. Here, I have seen in an area of California that is the Central Valley, where most of the manufacturers are limited by the amount of water that they can use. And sometimes for some of them, that is limiting their production. The amount of water is directly related to what they are producing. And so, yes, they start to try to be more efficient in their use. And of course, condensate is a big part of it, because as we mentioned, if you are able to increase your condensate return, then for them, that means that they don't have to use so much fresh water from the supply that they're using to to be using the boilers. So now they can use the same amount of water for their production process. So that means increasing production. So it's really a whole different science to be able to communicate with the manufacturers and understand what exactly are their motivations and what is the best solution for them. Because it could be energy, maybe as we mentioned, it could be reducing the water or the image. It's always so interesting to see all the variety of interests.
Katerina, earlier, when you were giving the example of your coffee manufacturer, you talked about how one of their key drivers and what was pushing them to undertake the project of this heat recovery and the recovery of flash steam was more about the visible emissions that they were seeing from the plant.
Yes. In that case, they were located very close to a big city. And this brand was worried about their sustainable image. They always advertise trying to become more sustainable. So, of course, if you see that on the TV, that sounds great. But for the plant with these huge plumes of steam on the roof, that wasn't the case. That is a big driver here in California, at least, because most of the plants are located in residential areas. Usually there is people living close to the plants. And I have not just that example, many examples of people, manufacturers that their main motivation is to reduce the plumes of steam on the roof because of the image. I have another manufacturer that tells me that usually the plumes in the roof call the attention of environmental authorities that stop by and ask, like, what is that plume on the roof? Because when you don't know steam, those plumes look like boiler stacks, or looks like you are releasing some contamination to the environment. And of course, we know it's not the case. A little plume of steam is not generating contamination. It's just moisture. maybe you are making that your city is more like a sauna, but it's not.
Of course, we have to emphasize that it is safe. It is safe. It's just costing money if you are putting it to atmosphere.
Yes, it is safe. It's just the image and the you can draw attention from authorities, and if you already, if you have big plumes in your roof, you probably have experienced this already. Trying to explain that it's steam and that it's okay, but sometimes it makes that the authorities get nervous. But no, it's environmentally safe.
It's a really great example there, and it sounds like actually, where you're based in California, it's a huge driver for an awful lot of manufacturers. And when we think about what we see on the news, when we think about when a site is often pictured in the press as polluting atmosphere, we often see plumes of steam misrepresented, which leads to that misunderstanding as far as the safety and the cleanliness there. So, thank you, Katerina, for sharing that story. So, we've spoken about how a manufacturer and how a plant can see benefit in realizing energy and water savings. We've also spoken about a reduction in CO2 emissions and also a reduction in visible emissions by condensing and then recovering their flash steam. But are there any other reasons why somebody should think about taking action when it comes to flash steam plumes?
Yes, of course. Another main driver for many manufacturers is the health and safety issues, or even maintenance. When you have a plume of steam in your roof, I have seen plants where, to don't make it so big, they use some type of vent head that condenses part of the plume, and then you ended up having water in your roof. And if there is an area where people is working, that is a risk factor because it's hot water on the floor. It can be slippery, you can get burned. And also for some other plants, it has been a very painful maintenance issue where the water starts to corrode the floor or walls.
We've really covered a number of points there, some of which are really quite obvious when we think about the energy and the water savings that could be captured, and then also explored some which are maybe less obvious when it comes to the water treatment and the heating or the reheating of water within the system, but then also the visible emissions associated with flash steam. And you also explained about the health and safety aspect there as well. So thanks ever so much. It's been a real pleasure talking with you. And Katerina, I hope you can join me again in a future episode of this podcast.
Thank you very much, Michael. It was a pleasure to speak with you this morning.
Thanks to Katerina Rosa for sharing her experiences around energy recovery from flash steam plumes, and in particular telling the story of the coffee manufacturer she worked with who needed to reduce the visible emissions due to pressure from the local community, while also looking to reduce their energy and water usage. In this episode, we discuss the true cost of flash steam plumes when they are left to discharge to atmosphere. If left unrecovered, not only do you have the direct losses from energy and water, they also present what is a visible issue for many sites and the surrounding communities as well. In addition, depending on where flash steam is discharging to, there can also be a safety risk to personnel on site, which can manifest itself as unexpectedly hot pipework or even steam condensing on a walkway and creating a slip hazard. There is a simple way to capture the energy and water and improve the working environment by condensing the flash steam and redistributing the energy into a heatsink. In the next episode, we're going to be exploring the practical considerations for implementing the most efficient plume-reducing flash steam recovery system to best deliver the benefits that have been outlined in this episode. Thank you for listening, and I hope you continue to join us on this series of Talking Steam.
Thanks for listening. We hope that you enjoyed this podcast and join us again soon. If you have any questions about the content covered in this podcast, please reach out to us or your local Spirax Sarco engineer. Watch out for future episodes coming online soon. Follow Spirax Sarco on LinkedIn and listen to get updates on new episodes.